Imagine, you have to travel to a faraway star system, light years away. This journey is so long that it feels like it will never end. You wonder, will we ever be able to travel that far? Is there a way to make this distance shorter? Even if we use the fastest spacecraft, the journey would still take thousands of years. It's hard to imagine how we would spend so much time in space. Our spacecrafts are not advanced enough to travel such long distances quickly. But what if we had a shortcut that allowed us to cover this distance instantly? But imagine if there was a shortcut. A cosmic tunnel that connects two distant points in space-time. This idea is so fascinating. You could travel from one place to another in an instant. This isn't just science fiction, but an important concept in theoretical physics. This is the mind-boggling concept of a wormhole. The concept of wormholes was first proposed in the 20th century. It's a tunnel that connects space and time, just like shortcuts in our daily lives. Imagine you're in a maze and you find a secret passage that leads you directly to the exit. Wormholes, also known as Einstein-Rosen bridges, are theoretical tunnels that create shortcuts in spacetime. This concept was proposed by Albert Einstein and Nathan Rosen in 1935. They thought that if we could fold spacetime, we could directly connect two distant points. This idea was so revolutionary that it shook the entire scientific community. Imagine folding a piece of paper and making a hole through it. This is a simple analogy that helps us understand wormholes. When we fold the paper and make a hole, we directly connect two distant points. This hole represents a wormhole, which connects two distant points on the paper, or in our case, the universe. This hole represents a wormhole, which connects two distant points on the paper, or in our case, the universe. If we could fold spacetime, we could directly connect two distant points. This concept is so fascinating that it has inspired science fiction writers and filmmakers. These cosmic shortcuts fascinate both scientists and science fiction fans, and they promise a future where interstellar travel might be possible. Imagine traveling from one planet to another in just a few seconds. This idea is so exciting that it has broadened our imagination. But how realistic are these wormholes? Are they just a theoretical concept, or can we actually create them? Scientists are still trying to find the answer to this question. Creating and stabilizing wormholes is a very challenging task. But if we succeed, it will change space travel forever. Can we actually use them to travel through the cosmos? This is a question that every space enthusiast has. If we could use wormholes, the entire universe would become accessible to us. We could explore other galaxies and star systems without waiting thousands of years. Let's delve deeper into the science of these fascinating objects. We'll understand how wormholes work, the challenges of creating them, and whether we'll ever be able to use them in real life. This is a journey that will help us understand the mysteries of our universe. The concept of wormholes comes from Albert Einstein's theory of general relativity. Albert Einstein, a German-born theoretical physicist, proposed his theory of general relativity in 1915. This theory fundamentally changed our understanding of gravity. Einstein showed that gravity is not a force, as Newton thought, but an effect of the curvature of spacetime caused by mass and energy. This theory describes gravity not as a force, but as a curvature of spacetime caused by mass and energy. Whenever a massive object, like a planet or star, is present in spacetime, it distorts the spacetime around it. This distortion is what we experience as gravity. Picture a bowling ball placed on a trampoline, causing it to sag. When we place a heavy object on a trampoline, it creates a depression on the trampoline's surface. This depression represents the curvature of spacetime caused by massive objects. This is similar to how massive objects warp spacetime. As the mass of the object increases, the curvature of spacetime also increases. Therefore, the more massive the object, the more spacetime warps. According to Einstein's equations, it might be possible to create a tunnel-like structure that connects two different points in spacetime. This tunnel, called a wormhole in theoretical physics, could provide a shortcut between two distant points. This tunnel is what we call a wormhole. The concept of wormholes is quite popular in science fiction, but it's also a fascinating topic in theoretical physics. If wormholes exist, they could dramatically change space travel. However, creating and maintaining a wormhole is not easy. Wormholes are inherently unstable and require exotic matter, which has negative energy density, to keep them stable. This exotic matter has not yet been experimentally discovered, so the practical use of wormholes is still a mystery. Imagine, we could travel vast cosmic distances in a fraction of the time, like we're on a cosmic expressway. This concept isn't just science fiction, it's also discussed in theoretical physics. Wormholes or Einstein-Rosen bridges are shortcuts in space-time that connect two different points. If they exist, they could allow us to travel at unimaginable speeds. This possibility makes wormholes incredibly alluring for space travel. Imagine having a technology that could transport us from one place to another without wasting any time. This isn't just a dream, but a scientific curiosity that inspires researchers and scientists. Imagine traveling to a distant galaxy thousands of light years away in just a few days or hours. This is a revolutionary idea that challenges our understanding. If we could harness wormholes, our space exploration capabilities could reach unimaginable heights. Wormholes could potentially act as interstellar highways, connecting distant corners of the universe and allowing us to explore the cosmos like never before. Imagine an interconnected network of wormholes that could seamlessly take us from one galaxy to another. This is a vision that could redefine our concept of space travel. This prospect has fueled countless science fiction stories, from the cosmic wormhole in Interstellar, where a team of astronauts travels through a wormhole to find a new home for humanity. This idea is not just entertainment, but also a part of scientific exploration. To the Bajoran wormhole in Star Trek, Deep Space Nine, where travel occurs through a stable wormhole. These stories inspire us and make us wonder if we will one day be able to travel like this. The concept of wormholes is not just imagination, but a possibility that could redefine our future space travel. While the idea of wormholes is captivating, their existence is purely theoretical. Several challenges and uncertainties need to be addressed before we can even dream of using them for space travel. One of the biggest challenges is the stability of wormholes. Theoretical models suggest that wormholes could be incredibly unstable and prone to collapsing faster than the speed of light, making them impossible to traverse. Another major hurdle is the requirement of exotic matter. This hypothetical form of matter possesses negative mass and energy density, which is unheard of in our current understanding of physics. Exotic matter is believed to be essential for keeping wormholes open and preventing them from collapsing. However, the existence of exotic matter is purely theoretical, and we haven't found any evidence of it in the universe yet. The most intriguing and potentially dangerous aspect of wormholes is their connection to time travel. Some theoretical models suggest that traversing a wormhole could allow us to travel through time, leading to mind-boggling paradoxes. Imagine traveling back in time and accidentally preventing your own birth. Such paradoxes raise fundamental questions about causality and the nature of time itself. Despite the scientific uncertainties, wormholes have captured the imagination of science fiction writers for decades. From classic novels like Contact by Carl Sagan to blockbuster movies like Interstellar, wormholes have served as a plot device for exploring the vastness of space and the complexities of time travel. These fictional depictions, while often based on scientific concepts, tend to take creative liberties. While entertaining, it's important to remember that science fiction should not be mistaken for scientific fact and the complexities of time travel. These fictional depictions, while often based on scientific concepts, tend to take creative liberties. While entertaining, it's important to remember that science fiction should not be mistaken for scientific fact. While the existence of wormholes remains firmly in the realm of theoretical physics, scientists continue to explore their properties and implications. Advanced telescopes and experiments might one day provide us with observational evidence to confirm or refute their existence. However, we are still a long way from harnessing the power of wormholes, even if they do exist. Overcoming the challenges of stability, exotic matter, and potential time travel paradoxes will require significant breakthroughs in our understanding of the universe. Wormholes offer a tantalizing glimpse into the potential for interstellar travel and time manipulation. While their existence is purely theoretical, the pursuit of understanding these cosmic shortcuts continues to push the boundaries of our scientific knowledge. Whether wormholes will remain a figment of our imagination or eventually become a reality remains to be seen. For now, they serve as a reminder of the vastness and mystery of the universe we inhabit. Don't forget to like, comment, and share this video. Subscribe to Space Fact Fusion for more amazing content on space and science.